Okay, this is differentiation in class practice number 7. And here's another sketch of the graph of the function that satisfies the given conditions. Now, there's a lot more on this one, so I'm going to go through all the clues, if you will, so we can do a nice sketch. So first of all, the important part is they tell me f of 0 is 0. So they told me one point on the graph is 0, 0. That's important. I always start out with that. The next thing they told me is f prime of 2, f prime of 1, and f prime of 9 are 0. So basically they told me at -2, -1, and at 9, those are my mins or maxes, or if you will, turning points of my graph. The reason why I know that is because the slope is 0. So when the slope is 0, that's where your graph is going to turn and all that kind of stuff. Then, what other information they gave us? Oh, they said the limit as x approaches infinity of my function is equal to 0. So that means when I go to the right, my right tail is going to approach the x-axis. That's like my horizontal asymptote, if you will, is y equals 0. Here, when I approach x is 6, now notice it's not a plus or minus, just a 6 of my function, it's negative infinity. This reminds me of a vertical asymptote. So I believe now I know at 6 there's going to be a vertical asymptote, and it's going to approach negative infinity. So probably on both sides it's going to go down the negative infinity because it didn't say from the left or the right. F prime is less than 0, so my slopes are negative, if you will, on these intervals. So you think about this, the slopes are negative, or my function is decreasing on those intervals. Okay, so that's good to know. From negative infinity to -2, 1 to 6, and 9 to infinity, my function is decreasing. Here it says my function is increasing on these intervals. So in between, if you'll notice, -2 to 1 is in here and 6 to 9 is in here. So it's going to be decreasing, increasing, decreasing, increasing, decreasing. So it's going back and forth. Now, the f double prime have to do with concavity. So if it's positive, I know this is going to be concave up on those intervals. And here it's negative, it's going to be concave down on those two intervals. And that's a lot. But what I would suggest that you do is shut this off and try to draw it after I get you started. First of all, I look at all of these points, every single one of them, and I see a 0, a -2, a 1, a 9. I came all the way up here to 12. So it goes from -2 to 12. So I kind of set my graph up like this. So I'm going to let you do that as well. Kind of set it up so I'm going from -2 to 12. The only point they gave us was 0, 0. Whoops, let me undo what I just did and actually make this red. So 0, 0 is on my graph. And they did say 6, it's going to negative infinity. So I'm going to do a vertical asymptote right there where my graph is not going to be. Okay, so I'm kind of setting this up. So I would shut the video off and see if you can sketch this. And the whole point is, guys, is you do a lot of erasing and practicing, and then you just check to see if every single condition they gave you was met. Okay? So I'll see you when you turn this back on. Okay, I'm going to start graphing this. So I looked at it, and they told us that it's concave up from negative infinity to 0. That helps us a lot. And I know it's got to go through this point right here. So I kind of just drew this like this. And I know it goes through the point 0, 0. So I knew that that was concave up. They also said less than 0, my function was decreasing. So it is. So it's decreasing and it's concave up. Then they said from 0 to 6, if you look at what you're from 1 to 6, they told us at 1, there's a turning point. So I'm going to come up here and do a turning point at 1. Doesn't matter where. And then they said it's decreasing from 1 to 6. So I'm going to go a little higher, I think. So I'm going to go a little higher with that. And I'm going to draw way up here. So it's going to come up and I'm going to have a turning point at 1. Then it's going to decrease. And it's going to go down to negative infinity. So it's going to come down like this. Now, I always check to see if I'm right, and this is kind of actually too much of a turn, so I'm going to curve this a little bit because only at 1 did they say there was like a turning point. So let me fix that a little bit more. This takes practice, it really does. So I'm going to turn it here and then just kind of come down to this and erase some of this here. It's kind of a bump there. Actually, my graph on my paper looks way nicer than this. Okay. And they said it was decreasing and this was concave down, so that helps me. And then they said to the right here at 9, there's also a turning point. So I'm going to do something like here. It's going to turn. It's going to come down to negative infinity there because they said at 6 it's going to do that. And then it's going to approach 0 and go concave up. And then I actually went and looked at all of this to make sure that it went and covered everything. So I got f of 0, 0. They said f prime of negative 2 is 0. At 1, it's a 0 slope, and at 9, so I kind of got that. Then the limit when I go to the right, I'm approaching 0, which I did. And the limit when I go to the left, when I approach 6, I'm going to negative infinity, and same with there. Then it's decreasing from negative infinity to negative 2, which it is. 1 to 6, it's decreasing, and 9 to infinity, so I did that. My function is increasing from negative 2 to 1, so it is, and from 6 to 9, which it is. Then it's concave up from negative infinity to 0, which it is right in here, and from 12 to infinity, so it's concave up over here like a cup. And then it's concave down between 0 and 6, this is weird looking, but it's concave down there. And then from 6 to 12, it's concave down to here as well. So I did all the conditions to sketch my graph. So I hope you practice this and get more comfortable, but don't be afraid to erase. Erase if you need to and keep doing it. Make sure you do all the conditions.